This is the first lesson on strings in Java, but I'm also going to include a bit of an explanation about how characters work because it's helpful in understanding the full idea of how strings are built. So first of all, characters are represented by the char data type. We did talk about that before along with the other primitive data types. Chars are just going to store a numeric value which represents that character. So characters can be anything like an A, like a closing bracket, like a percent sign, uppercase A, different from lowercase a, of course. And you can see these are all in single quotes, which means that the single quotes uh, are distinguishing a char from a string, which is in double quotes, because you could possibly have a string of length 1, which would be just one letter in double quotes. So that's completely different. So a char value, like I said, is really represented by an integer, and each of these characters maps to one integer value. So they're all unique. Obviously, they need to be that way. And just like any other primitive data type, it's stored in a certain number of bytes in the memory of the computer. The char would be stored in 2 bytes, and it's going to just store that number there. Whereas strings is going to be, we'll explain later, it's really an address of where to go find that string. Okay, so like I said, the integer values are codes that represent each letter or symbol. This ASCII code stands for American Standard Code for Information Interchange, and it's based on representing just English letters, uppercase and lowercase, punctuation, the digits 0 through 9, and it's a subset of Unicode, which is a universal code, which includes other languages as well, so that we can communicate across the world with a standard set of values, and the table doesn't change anywhere throughout the world, so it's standardized. Here's a screenshot that I just took from the internet. It has a pretty basic representation of the ASCII table. So this one here is shows a bunch of non-printable characters at the beginning. Some of the more important ones would be maybe a carriage return, which actually means the enter key. So the code for the enter key would be 13. Space, when you hit the space bar, it's 32. A 0, when you hit a 0 on the keyboard, it's 48. And thankfully, these go up in order. They stick a bunch of weird symbols in there, and then they come back to letters here, starting with uppercase letters at 65 beginning, and then at 97 begin the lowercase letters. And you may wonder why they stick a bunch of weird symbols in between and why they don't just continue. We can save that discussion for a later date, but there is a good reason for doing that. Okay, so characters, we have the primitive data type char, so we define it. Char, first char equals, in single quotes, letter A, second char equals single quotes, uppercase A. So we can also convert those back and forth into integers and then back from integers into chars. So that can be done with typecasting, as we're pretty familiar with from previous lessons. You put the data type in round brackets before the thing you want to operate on. So here we have 120. It's going to cast 120 into a char, and then it's going to store it into this char variable called third character. We can do the opposite. We could say, in single quotes, uppercase C, we want to know the ASCII code for that. We can cast it to an int, and we can print that thing. Also, characters, you can compare them using greater than, less than, equal to symbols. And these are all very simple to do. it just works as you would guess. When you looked at the ASCII table, these have different codes. So is this true or false? C being less than uppercase C. It's actually false, because if you looked up, if you remember, all the uppercase letters came first, so they were less, their numbers were less than the lowercase numbers. Seems a little counterintuitive, but that's the way they wrote the table. So this is sensible. The character for a 1, the digit 1, is actually less than the digit 4, which is a sensible thing for them to do. So that would result in true. So you can compare these because with greater than, less than symbols, equal, equal, not equal, because these are all really just integer values. This will not work for strings. We cannot use greater than, less than for strings, and we cannot use equal, equal, and not equal. We'll talk about that later. Here's a pitfall that you'll probably run into soon enough when you start working with strings. Here in this program, we have two letters, letter 1 and letter 2. They're both chars, and we simply want to join them and output AB. But there is a problem. This, when I join letter 1 plus letter 2, and I go to print it, it prints 131. So why is that? Well, that's because it's really just adding the numeric codes for those letters. If you remember, uppercase A was 65, so B would therefore be 66. When it adds them, it gets 131. So again, that just happens because it's just adding the numeric values for the codes. So if we want to overcome this problem, we have to convert a char to a string and then join them. So there's actually a very simple way to do this. All you need to do is join an empty string, like empty quotation marks, to a char, and then that'll convert it. So in here, if you have empty quotes for a string and you join it from or to the single quote A, which is a char, it'll turn it into double quotes around the A, which is a string. So a string plus a char is going to give you a string result. So this is a quick way to convert a char to a string. Now in this case here, because computers evaluate expressions from left to right, if we take the single quote empty string and join to letter 1, this entire first part gets converted to a string, and then you can add on another char, and it's adding a string plus a char, which will result in a string. So in this case, it works to give you AB. So to start with strings now, they're just composed of a bunch of individual characters that are linked together or strung together. That's why they call it a string. So some examples of strings could be, my name is Mr. Benham. It could be involving just digits and symbols, like the second example. Strings can really contain anything, like a phone number. It could be brackets and dashes. Even though it does contain letters and numbers, it's a string. So you'll also notice that there's something different about string data type. String starts with a capital S. That means it's a class. So it's not a primitive data type. This means that a couple things for you. Strings actually, since they're a class, they can have a bunch of methods that help you operate on the data that's stored in there. So we'll find out what are these methods that we have for strings shortly. But for now, all you need to know is that it's not a primitive data type. It actually stores an address in it as to where to find that string in the memory. So we can't really predict how long the string is going to be, so we don't know how many bytes it's going to need to store that data, so we can't have a fixed data type like we do for int and char and boolean and double. So you can make a string using a constructor. This would be like when we made a random object or made a scanner. We used a constructor like equals new, and then the constructor name bracket bracket. We can do that for string objects as well because they are objects of a class, but it does look quite long and tedious to do this just to make a string. So instead of doing this, Java provides a shortcut. You can just simply state the data type string, S1, and then set S1 to hello, for example, in quotes. So you can do it all in one line if you want. Another tricky thing that comes up is when you're getting input, you have to decide, are you going to use the next or the next line method of scanner? Because the scanner class has two different ways to obtain a string. Next is good if you just need a single word, whereas next line is if you want a whole line of text until they press the enter key. So for example, if you're just asking for somebody's first name, you can use next. But if you're asking for their whole name, which would include first name, space, last name, you might want to use next line because otherwise it's going to cut off after just the first name. So yeah, so you just set up your scanner, you ask them for a word. If it's just a single word, you can say input.next, and it stores it into the string variable word. If you want an entire sentence, then you're going to have to use this one where you say next line, and that will get an entire line of text. So strings, they're indexed starting at the number 0. So you kind of label each letter in the string with a numeric value. That's called its index number. So if you want to refer to the first character, it's actually letter 0. And the second one is letter at index 1. This can be a little bit confusing when you get started, but after a while it just becomes second nature and it's not a problem. So of course that means that the last character of a string would be found at the index, which is the length of the string minus 1, because since we started counting at 0, the last letter would be 1 less than the length. So what is the length of the string hello? Well, it's 1, 2, 3, 4, 5 characters long. So the index of the last character would be index 4, would be where the O is. And this question here says, what is the index of the second L in the word hello? So that would be 0, 1, 2, 3. So 3 would be the index number for the second L. So as long as you remember you start counting from 0, it shouldn't be a problem. So I'll just present two more methods for strings, and then we'll stop there because I think that that's probably enough for the first lesson to get you started. So string methods, there's a lot of them, and I'll provide you with an API documentation sheet that you can print out if you want and use as a reference as we go through the chapter, learning about strings. The first very useful method is the length method. So as we know, methods are called from objects. So string name is the object, which is storing a string. We don't know what string, we don't know how long it is, but if we run that name of your variable dot length bracket bracket, it's going to return the length of that string. And remembering the first element of the string is always 0. If we want to get a character at a specific position, there's a method called charAt. So if we say charAt 3, that's going to give us the 4th character in the string because we started at character number 0. So if you wanted to get the first character, you would say charAt 0 from your string. I'll just mention quickly, there is another way to get a character at a position, and that is using the substring method. The substring method is more flexible because it can get you any part out of a bigger string. And in this case, I'm just getting one letter. The tricky thing with substring is that this method, the first parameter, which is the 3 here, is the starting index. The 4 is the ending index, but it's not inclusive of that number. So it's a little bit confusing, but in this, when you say 3, 4, it's only actually going to get you character 3. but it returns it as a string rather than as a char. So it'll be a string of length 1 in this case. So that'd be good if you wanted to extract one letter and you wanted to keep it as a string for a certain reason instead of doing charAt, which returns you a char. So for the example here, if we take Thornhill, then we say dot substring 3 to 4, it would go to character at index 3, which is 0, 1, 2, 3 is the R. And since it's not inclusive of the 4, it would just only get you the R. But you can see how it's in double quotes, it returns you a string.